is 120.
So we're talking about
Really? Or
it's a
what?
new chapter. Okay, new section called the nth root, right? A lot of the time we are used to like finding square root, and this is pretty much what we do in like algebra one and maybe pre-algebra somehow. Now we're gonna try to do higher
Are we using
order.
eyes?
Excuse me?
Are we using eyes?
We're gonna be using I at some point. So now we have like square root, right? So when I say square root of 4, what I mean by that is this. What number multiplied by itself twice gives you 64? What's the number? 8, right? So square root of 64 is 8. So everybody knows that, right?
It's that little 3.
So when you have a square root, what you're really saying is, this is called the index. The index is 2, but we don't write that. It's like we don't write that. When you write square root of 64, you don't write the 2 there, but technically there's a 2 there, right? Now to differentiate between this and that, now this is called the cubic root, right? Because it's a third, so it's the cubic root. Okay? So the question is this. This reads cubic root of 8, which means what number multiplied by itself 3 times gives you 8? 2. So the cube root of 8 will be 2. So it's not such a hard section, honestly. If you understand the mechanism, it makes it really easy, right? Now we have the same question here. This is called, when you have a 4, which is the fourth root, right? Or, so what's the fourth root of 81? 3. Basically, what number multiplied by itself 4 times gives you 81 is 3. If you want to break it down,
How would
you
you
can do that.
How would you solve that then?
So while you break down 81, right, you can use the factor 3. A lot of people do that, right? 81. If you break down 81, that is what? 9 and
9.
9. And 9 is what?
3.
And 3, and this is 3 and 3, right? So I mean 1, 2, 3, and 4. So
What
this is
about-
basically 3 to the power of what? 4, right? So that means the fourth root of 3 to the 4 is just 3. Because these are matching, you just drop it, you get rid of the radical, so you're left with 3. That's technically what we are doing in this section. Okay? It's the same thing with this one here. If I were to break down 8, 8 is 4 and 2, and we have 2 and 2. So this is basically cube root of 2 to the third power. Since these are matching, you just drop the radical, so you're left with what? A single 2, right? So that's what we're doing here. We are just finding. Now, I put n, because n could be any number. N could be 1, 2, 3, 4, which we've done here. Or it could be 6, it could be any number. You just have to make sure you match it up correctly. Do I have a question here, or are we good to continue? Any question? No. All right. Now we have to do some examples. So here I have plus or minus. This is just a regular square root of 16y to the 4. So what is that going to give you? 4y squared. Plus or minus?
4y squared.
4y squared, right? Because square root of y to the 4 is y squared. Okay, you got to be careful with the understanding the mechanism. Okay, square root of 16 is 4. Square root of y to the 4 is y squared. Because here on the outside we have an imaginary 2. Okay, so this will be plus or minus 4y squared, right? Moving on to this one here. Actually, I will save this one last. Okay, a little complicated. So now I have negative x squared minus 8 to the power of 8. I want to find the square root. What's that going to give me?
Should you start with what's inside of the...
You start with exponent is what we look at, right? It's easier. So this is technically is an imaginary 2 here, right? So an imaginary 2. So what do you think I'm going to get?
X minus 4.
It doesn't change. Nothing on the inside changes. The only thing that I'm looking at is the exponent, right?
So is it
X minus 8.
minus 8 times...
You mean x squared minus 8?
X squared minus 8.
To the power of what?
4.
4. And then forget the
Minus...
negative, right? We are not looking at the inside expression does not affect the outcome because this is all raised to the power of 8, right? This is a square root, so that means you want it twice. So this is to the 4. That makes sense?
Yeah.
Any questions on that?
So
If no number is written, it's always just 2, since it's just a square root.
Yeah. If there's no number, you assume that this is a 2.
So you just take it out of the square root before you solve it.
You took. I don't know if I understand what you're saying. Like, explain that.
Like, are we gonna solve it, or are we leaving it like that?
You're done when
Oh,
you
is
get
it?
here.
Okay.
That's it. You don't do anything else, right?
Right.
Because you want to get rid of the radical. Okay. So here now we have. What would you call this? Yeah.
Simplify there.
I don't need to. Why would I want to simplify? Because you're gonna do it 4 times. That's gonna be a huge number. You want to do that? Probably not, right? Because you're gonna do how many times? This times that times that, and that's just gonna be a huge number. You just leave it alone. Don't make it any harder on yourself. You can if you want, but if you stop here, you'll be fine, right? Now here we have a 5, right? Now before I go on, you gotta be careful. Some people, this, right, is not the same as this here, right? You see the 5 here is in the radical. Right here is outside. This is 5 square root of 16. This is red, the 5th root of 16. Right? We have to be careful how we read this. So you need to understand the distinction between the two. Okay? Now, this is the 5th root of what? 243. So what do I have to do to make it easier on myself? First, let's take it one at a time, right? These are going to be easy to break down, aren't they? Right? But then we need to look at 243 here, right? I'm going to break it down. So that is what? The easiest number that goes in, I think, is 3, because if you do 2 plus 4 is 6. 6 plus 3 is 9. When you add the digit of a number, and if it's a multiple of 3, that means that number is divisible by 3. Right? So it would be what?
You can do it with 9 too.
3 and 9 or 9, whatever, right? So it would be 3 and
Do I just find
81, right? And this is basically
9.
9 and 9, right? This is 3, 3, 3, 3. So I got 1, 2, 3, 4, 5. 5, 3. So I'm going to rewrite this as cube root of what? 5th root of 3 to the 5, a to the 20, and b to the 25. Now I can solve this, right? So that's going to give me what? The first one is going to be
3,
3,
3, 4,
a to the 4,
5.
b to the 5, right? So all you do is just, you look at the exponent, you divide it, and whatever you get is whatever you get. You get rid of the radical. So this is 3, a to the 4th, and then b to the 5.
We're just making it simple as it can be.
That's it, yeah. Making it simple by getting rid of the radical. You're trying to like simplify that, yeah. All right, now we have a different expression here. Now, the problem with this one here is I have a negative under the radical. So automatically we have to use what?
Take I out.
I out. There you go. Take I out. Good. So you have an I out. Let's begin with I right here, right? Now, what's square root of 16?
4
4. What's square root of x to the 4? X what?
squared.
And then square root of y to the 8? Y to the 4. Because this is, I can imagine 2 here. So do you see how this is actually really pretty simple stuff, right? It's not that complicated. If you once you understand the gist of it, it's just applying that. If you have a square root, you know that everything is all the exponent are going to be divided by 2. If you have a 5th root, this is 5, 3, by 3, so on and so forth. Now we're going to learn how to simplify using absolute value. Okay? Why do I say that here? Now, if I was to simplify this, right? Let's say you didn't know anything about this. What would you get here? I have 4y to the 4th.
Just y.
Y, right? But the danger is just putting y is this. Y could be a negative number. Couldn't it? Could be a negative number. So that means this would be a false statement, right? If y is a negative number, this would be a false statement. So therefore, you have to put absolute value of y. And let me explain why I'm saying it. The exponent of y is what? Here. 1. 1 is odd. Because it's an odd number, you can have a negative. So anytime you take you have an even number, an even radical, and you take the root of it, and you get an odd number, a number with an odd exponent, you want to make sure you use your absolute value to avoid any danger of possibly saying that this number here is negative. Does that make sense?
Can you just use absolute for all of it?
You can use absolute for all of them, but you don't have to. When you have this, use absolute, right? For example, here, what would that give me if I was to do this here? I have the 6 root of 64, right? First, I'm going to break down 64. So that gives me 8 and 8, right? And 8 is what? 4 and 2. 4 and 2, that is 2, 2, 2, 2. I got 1, 2, 3, 4, 5, and 6. So this is like 6, 2 to the 6, and then x squared minus 3 to the 18, right? And if I was to do this now, what would that give me?
2.
2, and then what?
X squared.
Squared minus 3.
To the power of
3.
Okay.
Is it
3, right? 83. But because this exponent is odd, what do I do? I'm going to add absolute value to avoid, because I want to make sure that the number that I'm getting is not negative. So this is why I'm putting absolute value. Anytime your exponent is odd, you want to do that. Yeah.
So would you do that for 3A, 4, B5?
B5, yes, technically I should have done it for B here. I should have put B to the 5 here because
But you wouldn't do it
this is-
for the rest of
I wouldn't do it for here because all the exponent are what? Even.
I mean, like, you wouldn't do it for the...
No, I wouldn't do it for that because in any number raised to the power of an even number is always going to be what? Positive, right? But here, good observation, I have to put in B to the 5 so that it's an absolute value, right?
Yeah.
So this is technically section 6.4, the end root. Very simple one. So now I'm going to give you some work to do. So that's it. No, hard, right?
You only have to put in absolute value